So I don't do PowerPoint, sorry. This is just a GitHub Markdown wiki, because then I get version control. So I don't really do interesting talks, I do very technical talks. This is going to be, probably, can you read that? Well, it's probably going to go off the edge now in some of the slides. This is going to be about serialization exceptions and memory leaks. So can I get a show of hands how many people have had a Spark job spit out an exception of the form task not serializable? Great. So I'm pleased there's lots of people who've had that exception in a way, because that means that my talk isn't pointless. I'm sure you're all kind of aware of some of the ways to prevent these problems. There's a few solutions on the internet. I'm going to say that most of them are wrong and that there's a different way of doing it. And I'm going to ask lots of questions. When I say ask lots of questions, I'm going to give lots of examples to try and make the problem clear. What is the problem? So there's two, yeah, I knew that was going to happen. So there's two kinds of exception you get from, there's two kinds of serialization problems you can have. So they have one when you've got object data, so that's your data you're dealing with, is not serializable in some way. So when you try and broadcast it, when you try and collect it, or when you try and shuffle it. They're easy. They're the easy ones. The hard ones are when you're trying to, you sort of accidentally, unintentionally or intentionally serializing or trying to serialize non-serializable metadata via transitive closure capture. Do people have a rough idea what transitive closure capture is? Just nod your heads. Okay. So it's basically scope. It's to do with a problem of scope. So most people will be familiar with scope. Every block of code or method or class has a scope. And what happens is when you provide a function to a operation in Spark, it will capture everything. Well, you may have a reference in your function to something else, and everything within that scope may get captured, and this will hopefully become clear what I mean as I go through the talk, and it will actually make sense hopefully by the end of the talk. If it doesn't, then you'll have to look at the slides afterwards. So the other thing, and this is less common, people would admit to or know about, is they've actually got memory leaks instead of exceptions. So sometimes you have some metadata that is actually large. It could, or it's slow to serialize and deserialize. So sometimes serializing and deserializing stuff is really slow. It could be what I kept getting caught out by was doing a collect because I wanted to create a big map, massive hash map or something, to avoid joins because I've got an algorithm that is going to need to repeatedly do some joins. So I would collect things, manipulate them, turn them into something else, broadcast them out. If you're not careful, then you may end up broadcasting out things you don't want to broadcast. And then you're using up memory, and you're also using up a lot of time. So this is a tricky situation. So let's start off easy. So I don't know if you want to shout out or show hands. We've got a class not serialized, but we make a silly RDD, and we map things to this tuple with not serializable, and then we count it. Will this cause a serialization exception? Yeah, who said yes? No, it won't. It gives you the answer. Because if we go back to a few slides, it has to be collects, and you have to move the data around. You can have data that's not serializable in your RDD, it doesn't matter. When you try and move it, that's when you're going to get the problem. So will any of these cause a serialization exception? Yeah. So these all will. So that because we've got a group by key and then we count it. We've got a collect and we've got a broadcast. So they're the easy ones, and now we're probably going to move on to the harder ones. So yeah, the lesson there is you can have non-serializable data in an RDD. So apologies for anyone who doesn't really do Scala. There will be a bit of Scala in this. It's mainly around the syntax and sugar in Scala. Will this, so have some time to look at it and then say, shout out if you think this will cause a serialization exception. So this one will. So what's happening here is, well, let's move on to the next question and then I'll explain it. So can I have, so this will, only a few, hopefully someone will get this. Who can add 3 characters to that line to get rid of the exception?
Int, Hasnik. 2 slashes.
Okay, so here you add this parens underscore parens, and this basically expands to this syntactic sugar. This is sugar for this, and most people will be familiar with this. So why doesn't this cause a serialization exception when the previous one did? Because we're creating an anonymous function, and an anonymous function by default in Scala, it'll give you a serializable anonymous function. So the important lesson here is map something. Okay, let's move that up a bit. Map something is not always the same as map x to something x, okay? You think it should be, but it's not in all contexts, particularly in Spark. And to demonstrate this, we've got just a function that throws an exception, just throws an exception. And here we take a list, we map silly function. Here we take a list, we map and we wrap it in an anonymous function. Now the proof is in the stack trace, that these are kind of different things, because this stack trace is bigger than this stack trace. It has to go through more frames before we get to this traversable-like thing, and that's because of the extra wrapping. Sometimes that extra wrapping can fix your code. Sometimes it can break your code, and there's a lot of subtleties around that. So moving on. So what about this one? This is probably the worst one, or one of the worst ones. Any guesses? It's a binary question. Okay, fine. Yeah, that one will cause a serialization exception. It's a bit weird. By the way, for methods, these two things are the same. And that's when you've got a method. Scala, this is syntactic sugar for this. Lambda gives you a function, but so why did it just give us a serialization exception when just ignore that for the meantime. But why did this give us a serialization exception if this is essentially what it's doing? Well, if we go back, and this is the problem to do with closure. is we only want to use add 1. We only used add 1. We only use add 1 here, but and NSA is the thing that's not serializable. So that happened because of, this is the problem of closure capture. Any value or field or thing inside a class, if you try and use it, you're then going to serialize up the whole class. Oh, and this is just a demonstration that these two things are the same because the stack traces look kind of similar. So what about this one? Same. So this one doesn't cause a serialization exception. And that's because of the yes, so here we've got a function. That's right, we've got a function. We're creating an anonymous function, which is serializable, and we're passing it in here. We're not wrapping it in a lambda. So just this thing is being serialized. Okay, so let's see if we've got it now. Can we add 3 characters so that this will cause a serialization exception? So yes, we can. And we can add the parens underscore parens, because now we're wrapping it in a closure, which means this chap then needs to be serialized. Whereas if we didn't have these guys, this guy wouldn't need to be serialized.
Everyone's wondering why a Python API exists.
Well, okay, I'm not going to go into that because I've been given 20 minutes, 30 minutes. What I think happens, I don't know for sure, but what I think happens in Python is it does a lot of stuff, serializes just a load of stuff, and you don't have a choice.
So it's pretty much also reliable by default, isn't it?
Yeah, whereas you get a bit more fine-grained control over what is and is not being serialized in Scala. Now don't take my word for that, I'm not a Python guy. So anyway, I think this is the last one, I promise. So will this one throw an exception? This one's a bit more involved. We've got a not serializable class here. We've got something which should be serializable, apparently. It says it's extend serializable. It has a reference to this not serializable thing. We want to use add2 here. Will this one cause a serialization exception? Okay. So, yeah, this one does cause a serialization exception. That's because they're transitive. So we had to close over this thing. So we closed over this thing, which means we needed everything in here, which includes this, which is not serializable. And that's really annoying, because all we're using is add2. So this is, yeah, even though it extends serializable, doesn't mean it won't cause an exception. The reason why this is annoying, this can be even more annoying if this thing is large and it's serializable, or it's a config or something, and if you have a complicated application that has lots of, you're using lots of broadcast variables, you've got lots of big maps, you've got, I don't know, big models that you need to store in memory, because drivers have lots of memory these days. You can fit a lot of stuff in your driver. Sometimes that leaks out to all the other nodes. So that's what I mean by this. So here's an example where we've got a huge map. We're only using add2. We run this silly job. All it's doing is taking 1,000 numbers, add 2 to them, and then add them up. For some reason, it needs a megabyte of memory to do that, and it takes 5 seconds. So, okay, this is just on a toy EMR cluster, but the point is it still doesn't feel right, okay? If we didn't have the huge map, it's only a kilobyte or so of memory, and it takes half a second, which is a bit more realistic, or more what you'd expect, because it's got spin-up time and stuff. So it does make a difference. It can make a difference. A lot of the cost is really in serialization. I mean, if this is like, especially if this is a nested structure, if you've got a heavily nested structure, something quite complicated like a graph, or lots of nested maps, and serialization can become very expensive and slow. It used to be a lot worse in the older versions of Spark, because I think, well, I can't really remember, but they've made it better. So yeah, it uses a different amount of memory, it uses more time, and there's a lesson here, which is when you are using broadcast variables and when you just generally want to have one executor per node. Sometimes I see people from the MapReduce world coming from the Hadoop world coming over to Spark, and sometimes because of Yarn, they believe they need to have lots of containers on each node. Oh, I don't think that's a good idea. So here are the common solutions. Okay, so this kind of stops the exceptions, but it doesn't stop the memory leaks, which in complicated applications can cause problems. And that 3-character difference did actually make one of my applications work, because, yeah. So you can put @transient everywhere. What does that do? That basically says don't serialize this value. It's a bit ugly. You can turn all your methods into functions, and this might solve most of your problems, but I don't like the idea of throwing away a language feature. There has to be a better way. Methods have a purpose in Scala. Anyway, I'm not going to get into it. There's these strange things which allow you to sort of contain your closure. So you sort of explicitly declare what's going to go into your closure. And that's also going to happen with spores, which is going to basically be a lower boilerplate version of this and kind of natively supported by Scala. That'll happen in the future. There's a bit of a boilerplate overhead. I would say that spores is probably the best of all of these, and this is what we should be using. But I think we also need to shift our paradigm. And if anyone knows me, that they know that what that's going to be, which is to ban object-oriented programming. Stop using the reason why you get this transitive closure problem is because of object-oriented programming, and because there's no clear separation between behaviors and or functions and data. And this is apparently a good thing about object-oriented programming. I think it's just an unwillingness to accept that programming is an abstract discipline, and it's not like the real world. You're going to have to use something like functional programming to solve these problems. So what do I mean by functional programming? I mean it in the purest sense. Don't mix your data with your functions. So this doesn't mean using Scala is going to get you to that point. And it doesn't mean not using Scala either. So practically, this means don't put vals in objects. Don't put methods in classes. Use case classes only. Or if you are going to put your methods in objects or implicit case classes, which are a special kind of class, which aren't really classes, they just provide syntax. Now, if we stop here at the first 4, if we did that, we'd be limited to only have postfix notation. So we've got a function and then its parameters. And we don't like doing that, do we? We like we're like A plus B. We don't always want to have to do plus AB. And so to get around that, use type classes and implicit case classes. But don't mix data with your functions. So put all your functions in objects. Don't put any methods in your classes. So you've got a clear separation. One other concern might be, but then aren't we going to have to pass around a lot of parameters all the time? Because object-oriented programming, you have a class. In that class, you have some parameters. Then everything in that class has access to those parameters. And you don't have to keep passing them into your methods. This is how you control scope. Well, you can use implicit parameters to control so that you don't have so much passing around. You just wrap a context. You wrap things up into a context. I think that's why they call Spark context a context, and a lot of things are using this term context. These are things which you implicitly pass through your application. That's what I tend to do. So my Spark context doesn't get explicitly passed in, it's implicitly passed in and constructed in the main method. So one thing you will see if you follow these practices is you'll only see vowels will only really exist in the scope of a method, okay? So you won't have vowels anywhere else. I mean, everyone says vars are bad, never have a var. This is even going further. This is saying don't even have vowels. Well, have them in a method. So your scope and your closure is incredibly well defined. This might seem like overkill for serialization exceptions, which we could say solve with an at transient or a spore. Okay, this is also about, you're going to get loads of other benefits from this as well. And solving serialization exceptions and memory leaks is a side effect, but you also get a bunch of other benefits as well. So inheritance becomes purely for scope control. Inheritance won't affect an initialization order. Clear separation. You cannot break the single responsibility principle because each and every function is its own responsibility and you can't break that. Multiple inheritance is trivial. Discourages mutable state because there's nowhere to put your state. If you've only got vowels in methods, where are you going to put your state? You're not going to hide it in a class, you can't hide it in an object. Discourages encapsulation, which is a bad thing, by the way, in functional programming. And all your initialization code goes into your main method or is called from your main method transparently, like your H-based connections, your Spark context, whatever. You don't have to go digging for it. I haven't actually tested this one. Okay, I just hypothesized that you probably get faster garbage collection. I'm pretty sure you will. And serializing tasks will be faster. This is related to the closure problem. And from my experience, I have seen that. I learned these things the hard way in that I've written applications that serialize huge amounts of data really slowly. I've seen Spark run out of memory, not because of my data, but because of the actual overhead of serializing all the things in my application and doing what it needed to do. So, recap. So they're subtle. Try to understand the details. Don't just think that you've solved the problem because the exception stopped. You might be serializing it. Some people say, I'm using Sparkus not as fast as I thought it was going to be. Well, maybe you're serializing stuff you don't realize you're serializing, or maybe they're thinking, why am I getting out of memory exception? I haven't got that much data or whatever. You might be in one of these situations. And as always, functional programming is the solution. So I guess there's probably going to be a lot of comments. Are there any questions? Yeah.
So I understand the benefits, but like for example, I have a huge code base, and it probably captures code somewhere. I can sense it. So is there like a very nifty trick to make it throw some exceptions on compilations, or a warning, an inverted closure capture, something like that? Is there a way to do that?
Yeah, there is, kind of. If you don't want to go with spores, which is going to populate all of your code with a bit of boilerplate, I think what you can do is kind of try and make serialization explicit by using something like cryo. Because if you kind of careful in wrapping things in types, and you've got a nicely typed application, then you have to register. Then there's a setting on cryo where you say fail rather than using default serialization. And then you have to explicitly say which types are going to be serialized, which means if something is getting captured, which you don't know about, and it's not one of those types, then you will get an error earlier on. That's not really answering your question fully because it only works at the type level. It doesn't work any deeper than that. Maybe if they're using full code, like stage code generation in the next version of Spark, maybe they'll have help for this. My advice would be don't extend serializable, because then you will always be getting an exception. And since Spark 1.3, I think it's 1.3, but they put in this really cool thing where when you get a stack trace, it tells you what's not serializable, and it shows you like this chain of how to find it. I wish they brought that out a lot earlier. Yeah?
I was going to ask you basically before, you had a chance to look at what's going in Spark.
No, I haven't.
Because unless you're using the RDD API, which for most expensive purposes is going to go with any Java serialization and Client,
Yeah.
so I suspect. But while a lot of the rest of the line, you should always use case classes. But I suspect with serialization errors, sometimes you could go with
Yeah, they should do, really.
also the speed ups are awesome.
If they are doing staged code generation, they should be able to inspect it, and they should be able to, there should be not so many of these problems. I suspect you could still get memory leaks. Yes, because you will have, it will still, the same sort of problems will apply. And I imagine they're bringing out new awesome APIs, but there's still going to be the same sort of map and same flat map based functions, because people are going to need to write custom code. You can't do everything with just with data frames or what they provide you with data frames. So I think a lot of that will still apply, especially when it comes to memory leaks.
It's interesting because one of the things that we're willing to do is data sets are going to be on that level. Sure, you can use your own name objects. You can roll your own filters. That's going to be pretty strong.
Okay. Any other questions? Any other comments? Okay. All right. If there was anything you didn't get or you didn't agree with, just come speak to me afterwards. If there wasn't anything you get, I'm definitely going to give the slide. Thanks very much. Cheers.